So today we will see about what is the spanning tree of a given graph G. So graph G is normally represented with vertex B and edge E. So G is represented in a form of V comma E. So spanning tree is nothing, it's basically another graph, let's say G dash, which has vertex V dash and edges E dash. Now the number of vertex in the spanning tree of a graph will remain same, that is V dash equal to V, but the number of edges will be one less than number of vertex in a given graph. So E dash will nothing, it's basically a subset of E of a given graph, and it consists of number of vertex minus 1. The number of edges in a spanning tree will be 1 less than number of vertex in a given graph. So there are a lot of number of properties of a spanning tree that we generate out of a graph. So few things are highlighted here. So if you see point number 2, spanning tree normally it is basically a tree. So tree normally do not have any cycle. So whatever the spanning tree we are generating out of the graph, it will not contain any cycle. And second point, graph should not be disjoint in nature. It should not be disjoint in nature. If it is disjoint, then it is not a spanning tree. And third property you should know, for a complete graph, a graph where every vertex is connected to every other vertex given in a graph, that graph is known as complete graph. For a complete graph given n vertices, how many number of a spanning tree is possible? N raised to the power n minus 2. So that thing we can verify by taking any complete graph where every vertex is connected with any other vertex given in a graph. And if you want to generate a spanning tree out of that complete graph, how many number of a spanning tree is possible? That is n raised to the power n minus 2. So let's say there are 4 vertex and all those 4 vertex are connected to each other in a complete graph. So total number of possible spanning tree is nothing, it's a 4 raised to power 4 minus 2. So that is 4 squared. So 16 spanning tree are possible. So out of this 16 spanning tree, let's say every edges is carrying some cost, and that cost is represented by edge matrix or edge cost. So out of those spanning tree, which spanning tree is minimum? So that thing is known as minimum spanning tree. So from here you can understand the concept of MST, and that MST simply indicates minimum cost spanning tree. So there are several possible spanning tree, and out of that one spanning tree must carry a minimum sum total cost. So that spanning tree is known as minimum spanning tree of our graph. So this is the third point, and so that thing we can see from the graph itself. You can see the graph here. Let's say one example is written there. There are 4 vertex 1, 2, 3, 4, and I have tried to generate a 3 spanning tree with the cost written there. So first spanning tree consists of n minus 1 number of vertex, or case vertex are n, but number of edges are n minus 1. So that is the property of a spanning tree. So you can see the total cost is coming 6. While in second spanning tree, this is also spanning tree, but total cost is 5. And in the third spanning tree, removing one edge from the original graph, you are getting that particular spanning tree, you are getting a cost 7. So from the same graph of 4 vertex, you have generated, let's say, 3 spanning tree. And which spanning tree is minimum? Second one is minimum spanning tree. So that is the property of minimum spanning tree. Out of the total cost, which spanning tree is consisting of sum total as a minimum. And one more point is written in the point number 4. Given n number of vertex, e number of edges in my graph, if you remove how many edges you can remove at max, you can max n minus e plus 1. So given a graph, if you are removing maximum n minus e plus 1 number of edges, that much is permissible. Beyond that, if you are removing any edges, then your graph will become disjoint, and that will not be a minimum spanning tree. So that is the fourth point. So these are the few of the properties of, you can see, basically we can say about spanning tree. Now this is all about the beginning introduction of a spanning tree of a given graph, and in the next part of my video I will tell you how to use Prim's algorithm and Kruskal algorithm to find out the minimum cost spanning tree of a given graph. Thank you.